Hello students, welcome back. I'm Rinkesh sir, and today we will continue with exercise 10.4 of chapter number 10, that is vector algebra. Okay, so let's start with the exercise. Question number first, find magnitude of A cross B, where vector A, I will write down in simple form 1, minus 7 and 7, and vector B is 3, minus 2 and 2. First what we will do, we will find out A cross B. So A cross B will use determinant form like I, J, K. 1 minus 7, 7, 3 minus 2, 2. So this will be equal to I into minus 7 into 2 minus 14 minus 7 into minus 2, that will be equal to plus 14 plus j. Okay, so this will be equal to, sorry, not plus, second time we are taking minus j. 1 into 2, 2 minus 7 into 3, 21 plus k, that is equal to 1 into minus 2, minus 2 minus minus 7 to 3 minus 21, so it is minus of minus plus 21. Okay, minus 14 plus 14, that is equal to 0, so no need to write it down. 2 minus 21, that is minus 19, and minus, so it will be 9 plus 19j. Minus 2 plus 21, again 19, so it will be 19k. Okay, so now this is vector A cross B, but now we need to find out modulus of A cross B. That means magnitude. So this will be equal to under root of 19 square, 0 square plus 19 square plus 19 square. So root of 2 times 19 square. So root 2 and 19 square root is 19. So this is equal to 19 root 2. So the value of A cross B is 19 root 2. Clear? So this was about question number 1. So just note it down. Now let's move to the next question. Question number 2. Find the unit vector perpendicular to each of the vector a plus b and a minus b. Where a, let me write down in simple form, 3, 2, 2, and b, 1, 2, minus 2. Now see, you have to find out the unit vector. Now, unit vector only shows the direction. Now, what is the direction? Perpendicular to a plus b and a minus b. Here, so first let's find out a plus b. Let c equal to a plus b. So that will equal 3 plus 1, 4. 2 plus 2, 4. 2 plus minus 2, 0. And t equal to a minus b. So that will be equal to 3 minus 1, 2, 2 minus 2, 0, and 2 minus minus 2, that is 4. Okay, so now I have found out the value, or I have found out the vectors a plus b and a minus b. Okay, now we know that the cross product of any two vectors will be perpendicular to both the vectors. Means if I find out a plus b cross a minus b, then the resultant vector will be perpendicular to a plus b and a minus b. So what is our aim? To find out a plus b cross a minus b. Okay, let the vector n be equal to a plus b cross a minus b. Okay, so this vector will be perpendicular to a plus b and also perpendicular to a minus b. So this is equal to c cross d. Okay, so now let's use our usual formula I, J, K. C that is 440, D that is 204. So this will be equal to, okay, now this will be equal to I 4 4 are 16 minus 0 plus, not plus, minus J. So 4 4 are 16 minus 2 zeros are 0 plus K. 4 into 0 0 minus 4 2 are 8. Okay, so this will be equal to 16I minus 16J minus 8K. Clear? Now see, this is the vector in the direction perpendicular to a plus b and perpendicular to a minus b. But what's the question? It's not the vector, it's unit vector. Okay, so for unit vector, what I need to find out, I will take its unit vector of n, and that will be equal to vector n upon magnitude of vector n. So for magnitude of vector n, let's find it out here. Under root of 16 square plus minus 16 square, just a minute, plus minus 8 square. So 16 square, that will be equal to root 256 plus 256 plus 64. So that will be under root of 576. And that is equal to 24. Clear? So the unit vector will be 16I minus 16J minus 8K upon 24. Clear? So this will be 16 by 24. I minus 16 by 24. J minus 8 by 24. K. The required unit vector perpendicular to both a plus b and a minus b will be equal to 8 2 side 3 za, 8 2 side 3 za, 8 1 side 3 za. This will be equal to 2 by 3i minus 2 by 3j minus 1 by 3k. So this is the required unit vector perpendicular to both a plus b and a minus b. Clear? So this was about question number 2. Just note it down. Now let's move to the next question. Question number 3. If a unit vector A makes an angle pi by 3 with I, pi by 4 with J, and an acute angle theta with K, then find theta and hence the components of A. So see here, it is making angle pi by 3 with I, okay, and pi by 4 with J. That means the angle alpha, that is equal to pi by 3, angle beta, that is equal to pi by 4, and angle gamma, that is equal to theta. It's in this way. This is x, y, and z axis, and if this is a point, if this position vector of P, then the angles are, it is making with x axis alpha, with y axis beta, and with z axis, sorry, not this side, that is negative side, with z axis gamma. Clear? Okay, now first question is find theta and then the components of A. Now we know that if it makes angle alpha, beta, and gamma with x, y, and z axis respectively, then cos square alpha plus cos square beta plus cos square gamma is equal to 1. So cos square pi by 3 plus cos square pi by 4 plus cos square gamma, that is theta, is equal to 1. Cos square pi by 3, that means cos square 60 1 by 2 and its square is 1 by 4. Cos square pi by 4, that is 1 by root 2 and its square is 1 by 2 plus cos square theta equal to 1. So cos square theta is 1 minus 1 by 4 minus 1 by 2. The LCM will be 4. So it will be 4 minus 1 minus 2. This will be equal to 1 by 4. Clear? So cos square theta is 1 by 4. So cos theta will be equal to 1 by 2. So that implies the value of theta is pi by 3. Just a minute. Okay. So this was our first question, that is find angle theta. Clear? Now let's see the second, components of A. Now we have to find out x, y and z. That are the components of vector A. Now we know that if it is making angle alpha with x-axis, cos alpha will be equal to x upon its magnitude. Cos beta is equal to y upon its magnitude, and cos gamma is equal to z upon its magnitude. We are writing cos alpha equal to x by r, cos beta equal to y by r, and cos gamma equal to z by r, where r is the magnitude of vector. Cos alpha, we know it's cos pi by 3, right? So value of cos pi by 3 is 1 by 2 equal to x. And what is modulus of a? It is given unit vector. So modulus of a is equal to 1. X is equal to 1 by 2. Cos beta, beta is pi by 4, so cos beta 1 by root 2. So 1 by root 2 is equal to y by 1. And cos gamma, that is pi by 3. So cos pi by 3 again 1 by 2 equal to z by 1. So x equal to 1 by 2, y equal to 1 by root 2 and z equal to 1 by 2. These are the components of vector A. Or I can write it down, vector A will be equal to 1 by 2, 1 by root 2 and 1 by 2. Or 1 by 2 I, 1 by 2 I plus 1. The answer is 1 by 2 I plus 1 by root 2 I, j, sorry not I, it's j, plus 1 by 2 k. Now let's move to the next question. Question number 4. You have to show that A minus B cross A plus B is equal to 2 times A cross B. Okay. So LHS, that is equal to A minus B cross A plus B. Okay. So let's multiply A cross A plus B minus B. See, first I have taken A and now I am taking B cross A plus B. Now see, in cross product you cannot displace the position. Like if it is A cross B, you cannot write down it as B cross A. Okay? Because A cross B will be equal to minus B cross A. So I will not change the position. It will be A cross A plus A cross B minus B cross A minus B cross B. Okay. Now see, if we are taking cross product of the same vector, it will be always equal to 0 because both will be in same direction, right? We were having the formula like A cross B equal to AB sine theta. So it will be A cross A, then this will be A sine. As both are same vector, angle is 0 and this will be equal to 0. So A cross A, that is 0. And B cross B, that is also equal to 0. Right? Now A cross B. Now in cross product, also I can write down that A cross B equal to minus B cross A. Right? So here it's B minus B cross A. So if I want to displace this position, I would put a negative sign. So minus minus plus A cross B. And B cross B again same vector, cross product, so it will be 0. So this is equal to twice A cross B. Okay, and that is equal to LHS. Clear? So that was about question number 4. Now let's see the next, that is question 5. It's given that 2i means 2, 6, 27. I'm writing cross 1 lambda and mu. This is equal to 0. Now you have to find out lambda and mu. So let's take cross product. I, J, K. 2, 6, 27 and 1 lambda mu. That is equal to 0. So 0 I can write it down as 0i plus 0j plus 0k. Okay. Then I will write it on I. 6 mu minus 27 lambda minus j. 2 mu minus 27 plus k. So 2 mu, sorry, there is my mistake in j. Yes, it's correct. 2 mu minus 27. For k, it's with 2 lambda minus 6. And as it is 0 vector, I will write down 0i plus 0j plus 0k. Now comparing with j, I can get 2 mu minus 27 equal to 0. And comparing the coefficient of k, I will get 2 lambda minus 6 equal to 0. So 2 mu equal to 27. So mu equal to 27 by 2. Okay. And here 2 lambda, that is equal to 6. So lambda is equal to 2 ones are 2 threes are 3. So these are the value of mu and lambda. Clear? So this was about question 4 and 5. So just note it down. Now let's move to the next question. Question number 6. Given that A dot B is equal to 0 and A cross B is equal to 0, then what can we conclude about two vectors? So first, A dot B is equal to 0. Now there are three possibilities. See, what does this imply? Either magnitude of vector A is 0, then A dot B will be equal to 0, or magnitude of vector B is equal to 0, then it can be 0. If both are not 0, then the third situation is vector A is perpendicular to vector B, because A dot B is equal to AB cos theta, right? And if it is perpendicular, then theta is 90 and cos 90 is 0. So A dot B equal to 0 implies three things, three possibilities. Either modulus of either magnitude of vector A is 0, or magnitude of vector B is 0, or A is perpendicular to B. Let me write down. Because A dot B equal to 0 implies AB cos theta equal to 0. So if A and B is not equal to 0, that means cos theta equal to 0. That means theta may be pi by 2. Okay. Now second part. A cross B is equal to 0. So in this case also, either magnitude of A is 0 or magnitude of B is equal to 0. Okay, any magnitude of any one of the vector is 0, then the cross product will be equal to 0. Now what is the formula for A cross B? That is equal to A magnitude of B sine theta, right? And if this is equal to 0, and if magnitude of A or magnitude of B is not 0, that means sine theta will be equal to 0, and in that case theta is equal to 0 degree, because sine is 0 at 0. Now if the angle between two vectors is 0, that means both are either same or parallel vector. A cross B is equal to 0. Again, there are three possibilities. Either magnitude of vector A is 0 or magnitude of vector B is 0 or both are parallel. Now, if I take both of these cases, here both are given, means A dot B is also equal to 0 and A cross B is also equal to 0. So, in this case, both A perpendicular to B and A parallel to B is not possible. Okay, because two vector cannot be both perpendicular and parallel, right? So this implies that magnitude of vector A is equal to 0 or magnitude of vector B is equal to 0 or both can be 0. Clear? Okay, so this implies that when A dot B equal to 0 and A cross B is equal to 0, that means magnitude of any one of the vector will be equal to 0. Clear? So this was about question number 6. So just note it down. Okay, students. So that's it for today.